Syzygy episode 55, the Starlink Controversy. And welcome back for another edition of the Syzygy podcast. On this episode, we're talking about something which has been in the news lately, and it's, well, dare I say, a little bit controversial, particularly from the point of view of the astronomers in the room. Hands up if you're an astronomer. I'm looking directly at you across the table from me, Emily. We're talking today about Elon Musk and SpaceX and a little project of theirs called Starlink, which has got a few people in the technology world very excited, and has got a bunch of people in the astronomy world and elsewhere a little bit annoyed. So, Emily, what's Starlink? What are we talking about today?
Yeah, so this came to my attention for the second time actually this year because the Starlink satellites, which are a sort of cluster of satellites that are being launched by SpaceX, are interfering with some of the astronomical observations that are going on around the world. And this has started to lead to some very serious concerns by astronomers. And so I thought let's kind of talk about that. Let's debunk the myths that are going on about that and really have a conversation about, what is right in this situation? Because there may not well be one right answer.
Yeah. I mean, as with everything in this kind of realm, there are all sorts of different viewpoints, and we would like to present at least a few of those here today. And you can make up your own minds at home. I think some of the minds in this particular room have already been made up, but let's have a bit of a chat about it. So, a cluster of satellites. Starlink. What is it? What's it for? What's it doing?
Yeah, so Starlink is a project to launch, eventually up to something like 42,000 satellites, which are going to be in Earth orbit, which will provide internet, so satellite internet technology.
So this is a cluster of very small satellites. They're all quite tiny, but thousands of them. 42,000, did you say?
That's the project aim to launch 42,000.
But we don't have nearly that many up there now. They were only the first bunch of them were only launched a few months ago, is that right?
So there were 60 launched in May.
In May, right.
And then another 60 were launched in November.
Okay, so we've got 120 now, which is a tiny fraction of the 42,000 that are proposed. They're very small, and you might think to yourself, well, hang on. I mean, surely there's all sorts of stuff up there now. So adding another 100 into the mix, it's not a big deal, is it?
Well, so interestingly enough, so these satellites are small, but they're quite reflective.
Right.
So they're quite shiny, and they tend to be... it depends on where you are in the world, whether they come across as shiniest in your evening or morning sky, or even actually throughout the night, because it depends on your latitude as to what they appear to look like in the night sky.
It's all about the geometry of like reflecting bits on the satellite. It's sunlight bouncing off that, coming down to you, into your eye, or your telescope, depending on how you're talking.
Indeed. But these things come in clusters.
Yeah.
So what we're seeing is that astronomical images are being affected by big streaks of really bright satellites through the images.
So streaks, because it's not like you've got 60 of them or 100 of them spread out across the sphere of the sky. They're in a line.
Yeah, well, they're in a group,
in a
sort of
cluster.
a cluster. Yeah. So they sort of smear out and become these big lines in your long exposures.
Right.
So we saw this from several observatories in May, but what's really, I think, hit some of the news recently is that there were some astronomers working at Cerro Tololo, which is in South America, and they were doing some really deep sky imaging, and they came back to their images just after they'd been taken to find that several of their images had these enormous streaks all the way through them.
And like looking at deep sky measurements, you've got a long exposure, right? You're looking for long periods of time, which just gives more time for these clusters of reflective satellites to whip across your field of view. If you're taking a half-second exposure, chances are it's not going to happen. But how long are these sorts of exposures?
They can be a half hour, sometimes hours. It depends on how you've structured your observing. I mean, sometimes we take batches of shorter exposure times in order to do kind of difference imaging to try and remove, say, satellites that are, again, in the sky already, but are either faint or few and far between. There's lots of other noise sources that you might want to remove in cosmic rays and so on. So you tend to stack images, but when you get large amounts of these streaks, they can basically destroy an entire frame.
So that's not good in anyone's language. Surely this was thought about in advance. Like someone knew this was going to happen. Like, wasn't this discussed?
Well, I guess it depends on whose perspective you're talking from. So from the perspective of SpaceX, they don't seem to have really thought about or engaged with the impact that these satellites will have on astronomy. And their statements have been quite focused on things like, well, we're looking at doing worldwide internet. This is going to give broadband internet to something like 3 billion people who don't have it already, which is, an admirable goal. And they didn't really, I guess, work through the impact that this might have on astronomy and even kind of broader aspects of astronomy as well. So there's lots of different ways that these can impact, which I think is worth discussing as well.
I can see it just from a very obvious point of view that if you're trying to take images, take measurements of things in the night sky and something streaks across that's going to really upset your data. But can we look at that in a bit more detail? What impact is this having on astronomy at this point and potentially in the future with many more of these satellites?
So if we start with the imaging, which is where I guess some of the really impressive or very concerning visuals are coming from, then in May, for example, the satellites came up at magnitude 2 in the sky.
Now, what does that mean?
Which means that they were the same brightness as Polaris, the pole star.
Right, which is quite bright.
It's very bright.
One of the great things about Polaris, the pole star in the northern hemisphere, is that it's quite bright in the sky and it stays nice and still, so you can find where north is, and that's great. But it's bright.
It's bright.
And these are just as bright.
Or at least especially on launch. They may well get fainter depending on what final orbits they end up in.
Right.
But nevertheless, they're bright enough. Many of them are bright enough to see with the naked eye.
Astronomers spend a lot of time trying to study things which are not bright.
Exactly.
And so if you've got lots of really bright things in the sky that have been introduced by us, that's definitely not helping.
Yeah.
Okay.
And to be fair, we have amazing technology that we use to get rid of other sort of artifacts that come into data. So if we can do things like do jitter observations, which means that we very, very slightly move the telescope or the camera around on the sky. And what that does is that if you've got dead pixels or if you've got some particular part of the sky which is doing weird things that you don't want it to do, you can kind of get rid of those in very long images.
I see. So you can, I guess, guard against artifacts and weird things by saying, okay, well, we'll look at it from this angle and then just slightly change that angle and we'll get rid of anything that doesn't fit with how we expect that to turn out and we'll keep all the stuff that we want to look at.
If you realign the two images afterwards, anything that wasn't in both of them, you discard. Yeah. So, for example, that might be a satellite.
Sure.
Problem is that doesn't work if you're doing things like time series. Because sometimes we're interested in actually things that do vary in the sky.
Yeah, you don't have the luxury of being able to say, okay, well, we'll take one picture now and then in a couple of seconds or a minute or an hour, we'll take another picture because you're interested in the difference between those times. That is the thing that you're looking for. You can't just filter that out.
Exactly. So even in my field, we're interested in things that do vary and we're interested in variable stars. Some of these things vary in less than 2-minute frames. So we can't just get rid of half of our data because it's got satellites in them.
So the possibility of a magnitude 2 cluster of satellites whipping its way across your image just at the wrong time would suck.
Yeah.
Yeah.
And if you're really set up a sensitive instrument and you get something that's incredibly bright in your data, it can wipe out not only those pixels in your CCD, but it can actually write out huge chunks of your CCD as the readout happens. So what happens if you imagine a CCD as being kind of a set of buckets that are set out in a grid.
Okay.
Right? So the way you take the data off of that CCD is you take all the data to the edges. So you add up all the information that's in a row, say, for example, and then read that to the end. So the buckets, you would tip all the water from the top bucket to the second, to the third, fourth, etc., and then you read it out the bottom. But the problem is if you overfill one of those buckets, you can entirely destroy your row.
Everything's overfilled from then on. Right. So if you've got something set up to look for dim things and something bright comes along, it's stuffed your measurement, is what you're saying.
Yeah, you can lose whole chunks of your CCD.
Right. Okay, so that would be bad.
That's quite annoying, yeah. So these are some of the reasons, and the technology that we have to take out satellites, for example, as well as things like cosmic rays, which we do through both physical things like the jitter method that I said, but we can also do it in software. As well by having automatic processes that identify these things and kind of try and remove them. But they're definitely not sophisticated enough to deal with these kinds of
this is just too
disruption.
Much.
Yeah, exactly.
Is there anything that you can do in terms of, I mean, I'm guessing this happens. We know where certain satellites are. Like you can jump online and find out where the International Space Station is right now, for example. And, it's coming overhead. Look, there it is up there. Presumably you could time things so that you don't have the International Space Station coming across the path of your observation.
Yeah.
So one imagines that would be factored in as well. But that gets harder and harder as you introduce more of these things into the sky.
Exactly. And we do that. We do that for things like the International Space Station. We do it for the Iridium satellites, which are also communication satellites. But there's only 66 Iridium satellites.
Right.
So the maths to kind of figure out where your observations need to be is not terribly difficult.
It's not too
to
bad.
Avoid them.
So if we're introducing hundreds, thousands more of these little things, that becomes just exponentially hard / impossible.
Yeah. And one of the tricky things is that these satellites are actually really clever. So they kind of have an amount of autonomy on board whereby they can move to avoid, say, hitting other objects or indeed hitting another Starlink satellite, right? The problem is that when they do this, they change their orbits in a way that's unpredictable to astronomers on the ground.
Right. So that's not particularly helpful. So even if you knew where they were, that's no guarantee that that's going to be where they are tomorrow when you need to do an observation, because they might have used a little bit of their onboard AI to figure out where they should go.
Yeah,
Thanks,
and there's
Elon.
been no, at least as far as I'm aware, no discussion between SpaceX and astronomers as to giving out the information of their position.
So to be clear, I mean, this is impressive technology, right? And that's something that SpaceX excels at, right? They're doing some really amazing stuff in terms of rocket launches, getting things into space, getting things back from space, launching things up and then landing them back on barges and stuff again. Like it's good stuff. In terms of space exploration, it's amazing.
Yeah.
The technology behind what they're doing here, the potential of bringing broadband internet to the world, and a large part of the world that it would be much harder to have infrastructure laid out across the landscape. If we can do it in this way, that's amazing technology, particularly if you've got little satellites which are capable of going, oh, I'm about to bump into something big. That would be bad. Let's move it over here. That's amazing stuff. So let's just draw a line under, well done, everyone who worked on that. Excellent work. The contention is not that this is crap technology. The contention is that this is amazing technology that perhaps we needed a bit more discussion about before it was put into orbit.
Yeah, and I mean, I'm totally conflicted by this because SpaceX put Tesla into orbit, right?
Yeah.
And did a fantastic job.
Yeah, well done. That's great. Fantastic. Love your work.
Really
Could we
good.
talk about this one now, please?
Yeah, exactly.
Yeah.
So I've been and I have to confess, most of my research for this episode was based on newspaper articles. Forbes has done a particularly good job of covering both sides of this story, but also things like Facebook chats within the astronomical community, which is not my normal
As
go-to
we all
resource.
know, that's always a really good resource for news and current affairs.
But, okay, so I belong to a Facebook group of professional astronomers whereby we are discussing this issue and trying to figure out what is, going on and how do we need to have our voice heard in this situation.
Well, I guess that's kind of the point, isn't it? Is we are at the level, seeing as these were these were launched back in May, right?
Yeah.
And it doesn't sound like, although we can talk about this more in a second, it doesn't sound like there's been an enormous amount of consultation and agreement coming to between the two camps of, we want to make this technology, yeah, but we want to make observations. Hasn't been a lot of that conversation. And now we're at the level of, well, they're up there now. This is really hurting. What are we going to do about it? And that's a bunch of astronomers on Facebook having a chat going, oh no, what do we do? What are we going to do? And getting pretty cross about it.
So I have to say at this point that SpaceX have not been particularly compassionate with their comments back to the community. I mean, albeit through social media and Twitter and so on, which I did read through. There's an element of a belittling of astronomers' concerns. They're talking about little kids with little telescopes. which
that's not going to help.
That's not really going to make anyone very happy. But, some of the comments are things like, well, just move all your telescopes to space.
Which coincidentally would actually help their bottom line too. So,
well, indeed,
but
this is it really is impossible, right? We do a lot of work from the ground that is impossible to do from space. Yes, we have space telescopes that are absolutely necessary. We need to get into space to do things like X-ray observations, for example, because the Earth's atmosphere just blocks those wavelengths. But we do need to do things from the ground as well. If we talk about things like the best spectrographs in the world, HARPS, and these other wonderful instruments that are discovering exoplanets, you can't put those on a space telescope. They're too sensitive, they're too big, they require too much maintenance and personal care to be able to ever do that. And so for those reasons, we are investing billions in the next generation of enormous ground-based telescopes.
Which is not a bunch of kids just playing with a backyard telescope here. And it's, that's fairly insulting as a viewpoint to just sort of say, look, we're doing the important work here. You guys just need to go and figure out your own problems. What are you doing? It's arrogant, unfortunately.
It's unfortunate, yeah. To play down those kinds of things. So, there are statements that I quote that there's going to be no impact on astronomy. Well, sorry, but there already has been.
There already is, so no.
People don't notice the satellites that are already there.
We do.
Actually, Hubble is already having to remove satellites from its own images. So,
really?
Yeah, we have to take our satellites out of Hubble telescope images.
So okay, can we just back up a little bit here and have a think about the where are these things in space? I imagine Hubble being perhaps further out than it is, and these satellites being closer in than maybe they are. So what's the relative orbits of these things?
Well, the ranges are quite large. You go everywhere from a sort of International Space Station, which is very low Earth orbit, all the way to really, really high orbits. It just kind of depends on what science you're trying to do, if it's a science mission or indeed what communication you're trying to achieve. So geostationary orbits are quite low. So that's all the GPS satellites and things like that. So it depends. There is quite a large range, but Hubble is at the lower end of that range.
Okay. All right. Isn't it funny? I'd never thought of that before, but I imagine Hubble being like way out there, and actually, no, it's quite low. It's just up there.
Yeah. So we already do have to deal with the satellites that are there. And I mean, if you go and lie and watch the night sky for long enough, you will see a satellite that tracks through your vision, right?
Yeah. I mean, that's one of the one of the fun things about going out on a really dark night is not just seeing the infinite magnitude of space, but what's that thing moving across? Oh, there's a satellite. Look, up there. Up next to that really bright one, see the red one and the blue ones? It's just going across. There it goes there. And that's kind of cool. But if you've got a lot of those...
Yeah, so we have on the order of 4,000 current operating satellites in orbit.
4,000?
About 4,000.
So we're, in principle, about to add 10 times that number again.
Yeah.
Which is a lot.
So that means that actually, you'll be able to see most of these Starlink satellites if you're in the dark site with the right conditions. So if you imagine that there are going to be 42,000 satellites that you could see, well, there's only 12,000 stars that you can see in the night sky.
Wow, so that completely changes
from
the
the whole
sky.
Earth, from the whole Earth.
Completely changes it. Okay, right. So, how's this conversation going then?
So, well...
Because there's a bit of a chat that the two sides need to have here, or several sides. There are probably more than two.
Definitely.
There's the astronomers, there's SpaceX.
We have moved on a little bit from no impact on astronomical observations, thankfully.
Good.
I think there's some acknowledgement that there is going to be impact. We've moved to things like, we could move them for important astronomical observations.
Well, I guess if that's built into the device itself, then they could rearrange themselves to get the hell out of the way. That seems challenging, though, because it's not like...
There's a lot of telescopes
there's a lot
of
telescopes. There's a lot of different research. It's going on constantly all the time. I can't imagine that's a huge priority for SpaceX and the people behind the technology.
Well, and what counts as important?
Well, exactly. I mean, we have talked on this podcast on a number of occasions about discoveries and important research that's been done by not the biggest players in the field, but by people who are working on smaller telescopes, even backyard telescopes, making contributions. And they're not going to figure in anyone's calculations.
Or indeed the discoveries that you never knew you were about to make.
Yeah, exactly.
Which happen all the time.
Exactly. Yeah. Yep. Okay, so that's helpful, but not really helpful.
So there has been also a pledge to, in one of the upcoming launches, so the time frame for the next few launches is something like 60 satellites every fortnight for the next few months.
Really? Wow. So that's going to happen.
It's happening right now.
Okay.
So there has been a pledge to coat one of these satellites in black paint, basically. Just one.
What's the point of that? Is that so that we can say, all right, let's see the effect on that one?
To see if that works, to help the observations. I think it's fairly unlikely that, it will have enough of an effect, but B, actually, that will make them economically viable, because as soon as you coat a satellite in black paint, it's going to start to absorb more light from the sun. It's going to get too hot.
Right.
So I don't really believe
so even if that was helpful to the
solution.
astronomers, it's not helpful to the people who are actually launching and paying for the satellites, and so that's not really going to be terribly high on their priority list. Okay,
we'll see.
So
I mean,
not so
the
great.
fact is they're still going to be in the sky, so they can still transcend across your objects,
Yeah.
whether they're bright or not.
Yeah, a bright thing or a black thing is still getting in the way, is what you're saying.
Yeah. But I think, so where this is really interesting is also the other communities that have started to pick up on this conversation. So astronomers are concerned, and we understand why astronomers are concerned. But, this affects more people than just, little kids with little telescopes, shall we say. It affects people who, for example, build their work on astrophotography.
Right.
Which is based on very long exposures. As soon as you've got lots of satellites streaking through your beautiful images of the night sky, then that's going to be a real challenge for you to figure out how you even deal with that. I don't even know how you begin to deal with that as an amateur or even a professional astrophotographer.
I can't imagine that you could. I mean,
probably not. No.
A Photoshop filter, I'm sure, could be built, but it's not going to be flawless. That's crazy.
But then there's other things. So even other things that astronomical observatories run. So we saw these satellites not only in the deep space images that we were trying to get, but they also appeared on our weather cameras. Mm-hmm. So we have sky cameras at observatories that help us to see where the cloud is coming from, how the things are moving in the sky. So they were easily picked up on these cloud cams. So that means that they're going to affect our weather sensor technology from ground-based observations, but potentially even our Earth-based meteorology observations will be affected, because the meteorology satellites are higher, and if their data are interrupted, then that could potentially even impact our ability to forecast the weather. Quite dramatic.
Yeah, that becomes a problem, particularly in the current age of crazy weather and the importance of being able to, not just weather, but climate. It's really, really important that we take really accurate measurements at all scales at the moment.
Yeah.
So anything that upsets that should at least be discussed and not just dismissed.
We've got meteor cameras, for example. These are people who do all sky surveys,
Mm-hmm.
who look at meteor showers and where they're coming from in the sky, track them, measure their frequency distributions, etc. Those are obvious ones that are going to pretty heavily suffer.
What about people who are looking for large chunks of rock that might come and bash into us and wipe us all out like the dinosaurs?
Yeah, well,
that would be a
those
problem.
big surveys exactly are looking for tiny, faint things that are moving, so they're going to be really difficult to spot if you keep getting streaks through your images.
Yeah,
because most of the spotting is done automatically, right? It's done by artificial intelligence, by searching, because we don't have enough humans to actually do the search manually. So these are algorithms that are doing it, and it's hard to teach an algorithm the difference.
Algorithms which are now going to have to deal with another 42,000 things moving across their field of view, which is an issue.
And the final group of people that have raised concerns are radio astronomers. So radio astronomy is getting harder and harder in the modern world because we keep using more and more radio bandwidths, or channels, if you like, for communication. I mean, every time you think there's a new G out, whether it's 3G, 4G, 5G, whatever, those are new channels, right, that we're using. And so those are channels that radio and, in this case, microwave astronomers can't use anymore because they're being used by communications.
So when you say channels, you're talking about frequency bands, different bits of the radio spectrum that are suddenly filled with the noise of the world communicating and downloading stuff on their phones.
Yeah.
And no longer easily available to be able to study the universe with.
So there are protected bands for astronomy. They're protected, but not super well regulated. There is leakage into those bands. So we still have radio astronomers having to go into very, very radio quiet areas, things like the middle of the Australian desert. It's quite useful. Or indeed lots of other parts of the world, South Africa, South America, middle of the US. These are places we do radio astronomy because it's radio quiet.
It's got to be getting harder to find decent radio quiet in the same way that it's getting harder to find proper dark sky areas.
Exactly. Yeah. So, and when you have satellites that are broadcasting communication signals, you can't escape those on Earth, right? So there's a big concern from the radio astronomy community as well as to how you've got 42,000 satellites communicating. That's going to be very broadband communication.
Yeah, okay. So it's not just little kids with their telescopes in their backyards. There's a lot of different groups which are concerned about this. Can we talk for a minute about, so what are the rules? Like, can you just launch stuff up into space and that's all okay? Like, surely someone had to say at some point, we'd like to do this. We'd like to put 60 and then another 60 and then loads more bunches of 60 satellites until we've got thousands of them up into orbit. Thanks very much. Okay, we're going to go and do that now. Like, someone must have flagged something at some point. What are the rules?
Well, there's almost no rules.
Really?
So, there's one big rule when it comes to space. You can't use it for military purposes. That's an absolute no-no.
Okay, good. I guess.
Yeah. Okay, that's helpful. That's a good start.
All right.
Okay.
Yeah, let's remove that one.
Okay. But then after that, there's something called the Federal Communications Commission, in the US. So they control US
the
based
FCC,
projects. Now, they have given permission for 12,000 satellites. However, they are based mostly on the communications aspect of it. There is some control over who's communicating and what frequency bands, but there's no control over brightness, for example. So there's no consideration that was required as part of that proposal as to what the light impact of such a system would be.
So the FCC said, okay, so let's have a little bit of a look at what you're actually going to be using these things for. Does it fit within our guidelines? Does it cause any problems for other people who are doing similar sorts of things with these different bands of frequencies? Nope. Okay, good. Up you go. And that's it?
Yeah, and that's basically a US-based regulatory system. So it doesn't necessarily have the agreement of everybody else.
Anyone else. Everyone, anyone. Excellent. And it's in this one very narrow area of what the satellites are designed to do, which is communication.
Yeah.
It's the internet. It's spreading out the communication ability of the modern web to the world, which is great. And I'm glad that there's regulation about that. It staggers me that doesn't then spill over into, but there's this other group over here that also regulates putting stuff into space, and we should talk about that. No?
Not really. So the two voices that are here for the astronomical community particularly, on behalf of, I think, of the whole world, is the International Astronomical Union. So this is representative of all professional astronomers, but they also care about the general people as well, so they care about things like dark skies and so on as well. So they have issued a statement along with also the National Radio Astronomical Observatory from the US. So this is kind of representing the radio side. So both have issued statements saying they're deeply concerned about this project. They can't say a lot more, I guess, at this point. There are some individuals within those two organizations that are consulting with SpaceX, but it's not very clear to me who and what sort of how much their consultancy is being taken on board. When
you say they can't say a lot more, you mean because it's sensitive, because discussions are going on?
They just don't have any kind of clout.
Really.
Oh,
I see. Right. They literally like what, we've said what we've said.
We can say what our views are, but we don't have any power to stop.
You're telling me that the International Astronomical Union doesn't have lots of political power? Really?
Yeah.
Wow.
Surprisingly. Yeah.
Huh.
So they've issued statements and they've basically sort of said, well, think about this black hole image that we got earlier this year. Think how much that engaged the entire world with what astronomers are doing and how it inspired and just let our imaginations go wild with this amazing stuff. That sort of stuff will become impossible if we don't be careful about how we use the technology that we have in space. So that was their example of, this is the good stuff we're doing. Be careful with what you're doing that might destroy that kind of work.
Yeah, that's really quite troubling, isn't it? So, I mean, I guess all of this really does come around to, like, on the one hand, you've got amazing technology, which can do amazing things. And it seems like a bit of a theme in the world at the moment. We have amazing technology that can do amazing things. Have we really thought it through? No, but let's deploy it anyway. And then on the other side, you've got, but look what we can do in our understanding of the universe, both from a pure research and knowledge point of view, right through to an aesthetic point of view. There's beauty and wonder and awe at stake here. And those two sides are facing off against each other at the moment. And at the heart of that is who's got the right to do what with the skies? I mean, I get really ticked off when I go outside and I see skywriting. And there was a really big thing when I used to live in Sydney, and you'd go to the beach on a nice summer's day when the world isn't on fire. And you look up and someone's putting an advertisement in the sky from the back of a plane, spitting out smoke, spelling out the name of some product that they want you to buy. So hang on, that's my sky. That's all about, you don't get to do that. People have talked about, putting ads on the moon, which I just find utterly abhorrent. I find the notion of taking over the sky for commercial interests without consultation to be just really quite horrifying. Who's got the right to do this?
Yeah. So I have a few kind of open questions, and I'm just going to leave because they definitely don't have answers at this point, but I think that they're all things that we need to consider. So the first one comes directly from the astronomical community themselves. So the first one is kind of who pays for all our ruined observations. So telescope time is expensive, right? And the vast majority of telescopes, indeed all the time that astronomers will spend, the astronomers' time, all the technicians' time, everything, the very vast majority of that is paid for by public funded money, right? So that's where that comes from. And who pays therefore if some of those observations are ruined and we either have to spend more money getting more observations, or indeed we have to spend a lot of money developing new software and codes to deal with this? Because if that answer is public money, then I think that's a question that everyone should care about.
Yeah, I think that's very true. And particularly in an environment where, as we discussed before, if this is working in a realm where there is regulation, but it's not broad regulation, it's very, very narrow regulation around, communication protocols and so on. But there isn't broad regulation about any idiot can throw something up into space. Then public money demands some kind of, public scrutiny and public process. There should be say.
And let's make it clear, this internet that's going to be available from these satellites, it's not going to be free.
No,
someone's
there are
paying for
commercial
that.
Interests here. SpaceX is not doing this out of the goodness of their heart. There may be an element of that, and there are a lot of people, if there's anyone here listening to this show from SpaceX going, no, we want to change the world, that's great. My concern is, yeah, but have you discussed it? Have you really talked to everyone who might be affected by this to say, is there a way that we can meet everyone's aims? Or are you just, we can do it, therefore we will? Yeah, that's worrying.
Yeah. So then another one, my next question is then, well, who decides? Who decides that there might be impacts that actually have, or changes that are going to impact the night sky for everybody on the whole planet?
Yeah.
So this is everybody from people in the US who have effectively got regulatory commissions to say, yes, this is a good project, go ahead, to people in countries very far removed, countries with maybe don't even have technology. There are still people in very remote locations on the world who don't have any kind of technology who are going to notice that their night sky changes because it's now full of moving stars.
Yeah, it is a level of technological, I said it before, it's arrogance. It says we can do this and we know what's right. This is highest priority. It's our highest priority. And when you get this technology, this service, it'll be your highest priority as well. And everyone else's priority can go jump. And I think that's tragic because you can't reel that back.
Yeah, so this is a global conversation, just as much as climate change is a global conversation because it affects everybody on the planet.
Yeah.
So, and another question is actually, is the night sky something to protect?
Well, I mean, yes, it comes to the heart of whose is it? You know, whose responsibility, who owns this thing? And I would say a big yes on that, personally.
It's definitely a really new idea that we've come across. And this is what has formed, for example, the creation of dark sky parks. You'll find numerous of them across many, many countries around the world. And there's even sites which have applied for and gotten various levels of UNESCO protection for being dark skies. That means they're culturally important and we should protect them. Because what's interesting about the night sky is it's really is not just a scientific thing. It is a part of all humanity. It is a part of every culture that has ever looked up and created a story to do with what they see in the night sky.
It's our mythology. It helps to define who we are as a species. I'm gonna put this out there. I'm guessing that there are maybe a few people who are listening to this who it's been a very long time, or maybe never, that you've ever really gone out to a really dark place. And I would suggest everyone needs to do that at some point in their lives, as often as humanly possible, but at the very least once. Because if you've never seen a proper dark sky area, seen the night sky in one of these places, it will blow your mind. You think you know what the sky looks like. You really don't. If you've never seen the Milky Way stretching across the... Yeah. You've never seen the sheer... What do you do about that? I mean... the international, then you haven't had a full, proper human experience, I would say. I just go and do it. And you will, I think, get an appreciation for how meaningful this question is. Now, what do you do about that? I mean, the International Astronomical Union has said its bit, and I'm sure they're going to keep saying their bit as much as they possibly can. And you said that there are some conversations going on. What they'll lead to, who knows? What else can you do? I guess it's a little bit like anything else that's political. You can make some noise.
Yeah, so this comes to my next question. Who is the voice? Mm-hmm. Who is the voice for astronomers? And indeed, who is just the voice of anyone who cares about the dark? And I think, yes, the International Astronomical Unit and the NRAO have important roles to play. They are the key bodies that represent astronomers, but there's not a clear body that necessarily represents the public view on these matters as well. So I think we just need to start having the conversation amongst ourselves and starting to really make up our minds, is this what we want? And that requires not only us to have the conversation, but us to have all the information actually in front of us as well. So there's two things. There's a sharing of all the information, of understanding what is going on, what impact exactly it will have, but then asking the question, do we want this and what is the cost?
Yeah. Can I... It would be very, very tempting to do the modern standard practice at this point, which is let's all get angry. Let's go on social media and get angry about stuff and start slagging people off. I'm going to say a better way to do that is, and you know, this particular episode of this podcast is a start, right? We've provided some information, a lot of which is very, very new. You know, this is only months old. If you're listening to this and you feel stirred in any way to say, well, this is just, I need to know more about this, but it feels a little bit wrong. I don't like where this is going. Then use that as an impetus to go and find out more. Go and get some information and read up on it and get educated about it. Don't just throw yourself at social media and start slagging off at people. That never works. Ever. So go and find out. And if you want to get involved, if you want to start having that conversation, then start talking to other people and start sending information to people and start spreading this around, because this is important. And like with a lot of things today, we're not going to get a lot of chances to get it right. So
there are some government petitions out there, which we can put a couple of links into the show notes, depending on where you are in the world. But and there are also suggestions that are coming from my colleagues, such as writing to your local government, so your local representation, depending on how that looks wherever you are. But I think, just first of all, finding out the information and then just starting the conversation. Start the conversation with anyone you know. Start the conversation with your cat.
Have a practice on the cat.
Yeah. Yep. You know, this is something that I don't feel is being talked about enough, that I have to go burying deep into some of the news articles to actually find data about. So let's just bring it to the front of everyone's minds, and then we can globally be informed and make decisions.
All right, look, a lot to chew over in this particular episode, and it's perhaps a bit heavier than a lot of our episodes have been throughout the history of Syzygy.
Yeah, it's definitely been different in doing my research for this one.
Yeah. But I think the important thing for me is, as we said towards the end there, look, if this does matter to you, then let it matter to you. Go and find out some information. But be concerned, be angry even, but don't take it out on the next person you find on Twitter. Go and get some information, and then start having that conversation. Go and talk to people, whether that's your neighbour, your friend, your cat, your grandmother, whoever it might be, but also your local member of parliament, your local politician, your local representative. Talk about it, because the more we can get the conversation going, the more chance there is that people will actually come to some kind of decent decision about that. If we don't, then it's over.
Because there's no way that we're going to be able to create regulation that protects the night sky before this happens, right? This is happening now. We need to have the conversation now.
Yep.
And the only way that we can make any change in the very, very near future is by basically the voice of humanity.
So go and do it. Go and get educated and go and get vocal. Speaking of being vocal, if you want to get in touch with us here on the show, there's a bunch of ways that you can do that. Emily, if people want to see us on social media, where are we?
Yeah, you can tweet your support to us at SyzygyPod.
We're also on the Instagrams, same tag at Instagram. Facebook as well, we're on Facebook. We have a website, syzygy.fm, where you can find all of our past episodes, all of the show notes, all of the pretty pictures that we put up. It's all very cool.
It's an SYZYGY and usually a pod afterwards.
Usually, not always. You can find us on Patreon if you want to financially support the show, and we would be eternally grateful for those of you who do. And of course, the other way that you can support us is by giving us a review and a rating on your podcast client of choice. That's always a good thing to do for the podcasts that you love. Otherwise, we'll be back again in a week-ish or so. Emily, I'll catch you next time for some more awesome astronomy.
See you later.
Bye-bye, everybody.